Hello again, everyone, and welcome to another episode of A View from Earth, the official podcast of the Fisk Planetarium here at CU Boulder. As always, I am Tara. I'm a planetary scientist and a CU alum, also a presenter and outreach coordinator at the Planetarium, and of course, co-hosting this podcast with my friend Colin. Hi, Colin.
Hey, Tara, and also the listener. My name is Colin. I am an undergrad at CU. I study astrophysics and computer science, and I also work at the Planetarium as a presenter, usually when the building is open and we're doing shows. But hey, right now I'm also the co-host of this podcast, which is a lot of fun.
And of course, we have John here with us as well, hiding in the background. Hi, John.
Hello.
We'll force you to talk. So today we have a fascinating episode for you guys. I hope you're going to like it as much as we did. We are talking with Dr. Heather Demarest, who is a professor of philosophy. And in particular, she studies the philosophy of physics or science and how we think about science and how we relate to science and how science influences the way that we think and all of this interesting stuff. It's so cool. It was really fun to talk to her. I was just saying, I love this stuff. I could have talked about this all afternoon. It would have been amazing.
I feel like this is the sort of episode where, typically we try to answer questions on our show, right, that people might have, and they walk away with some answers. And I think this is the kind of episode where you'll probably walk away with even more questions than you came with,
Yeah.
There's a lot of conversation about stuff that was just very like, what does it mean? what's going on?
Yes, especially, and I think it's fascinating that she specializes too in especially quantum physics, which feels like to me, like even as a person who studies physics, it feels like its own philosophy at times. Like there's just, I don't know, quantum physics blows my mind. I can't get around to it. Give me rocks I can do.
There you go. Yeah, let's pick some craters.
Yeah, it's just so big and complicated, and there's so many theories. Like I feel like the different theories of quantum mechanics are essentially philosophical theories. It's
totally
all about interpretation, and I don't know, it hurts me. It hurts my brain.
Well, I one of my roommates is very interested in quantum mechanics, and we've had a lot of conversations about. Just the other night, I was asking, hey, what happens if sometime later in the future, right, someone figures out, and this might be a display of my ignorance in quantum mechanics, or to it, right? I haven't been educated on it yet enough, but I thought, what if sometime in the future someone figures out a way to show certainty, right, in position and momentum simultaneously, which for those who don't know, that's like a big piece of modern quantum mechanics, is that you can know one or the other or a little bit of both, but you can't know both of them simultaneously for certain, right? That's the Heisenberg uncertainty principle. And I thought, well, what if we could? Like, what if that's a limitation in the way we're thinking about it, or in our technology, or some other thing, right? The same way that people said we can never know what is, beyond the molecule or then the atom, and then we get better and we learn. And so would that then cause like full determination for the rest of time if we could predict accurately quantum systems? Is that it? And I think that it just extrapolates so quickly, because we're talking about the most fundamental piece of reality, the physical reality at least, and then it blows up really fast. It's very mind-boggling.
Or is it the most fundamental piece?
Yeah. Okay, Tara, thanks. Yeah, let's go ahead and stir the soup even more.
That's just the way that I think about things. There's so much, and part of it is, I did a lot of studies on the history of science and the way that it started and how we've moved through time, starting, all the way back from the Greeks and moving through to, Newton and even now. And so much science is just being disproven at every turn. Maybe not disproven, but some of it is definitely disproven. But, it's just there's so many changes that are happening all the time. And, this thing that we thought for hundreds of years, now we realize, that's not that's not right at all. And so I feel like so everything is just changing all the time, and there's maybe no certainty about anything ever.
Yeah,
That's just
right.
me.
Yeah, none of it means that. Well, yeah, yeah, exactly. It's we're all just here having fun doing science, and it doesn't mean
Yeah.
anything, and who cares?
It's funny though, because I feel like, especially recently, I've been doing so much work with kids, like K-12 groups, middle schools, elementary schools, and probably about half of the questions that I get from these, shows and presentations are very philosophical questions from these kids. Half of them are like, how big is the sun? Why can't this happen? Or why does this happen? But then, yeah, so many questions from these little kids are, so I had a seventh grader the other day ask me, does time move differently in space?
I don't
How do I
know.
explain general relativity to a seventh grader? um,
Seriously.
it's just, I feel like it all kind of goes back to that. It was something that Carl Sagan always pushed. We're all born scientists and asking all of these big philosophical questions, and then it gets beaten out of us over
Mm.
the course of public education. Um, but it really just, I feel like it really just highlights the way that science and philosophy really do go hand in hand. They're almost one and the same.
I feel like at the root, it's just being curious, and I think the distinction comes from, well, how specific is your curiosity,
How
and
badly do you
what,
want an answer?
yeah, right, exactly, exactly. Yeah, well, and I wonder why, obviously the current education system that we have, this is probably a whole other conversation, but we're here for some reason, right? We've landed here for some reason or another. And I wonder why it is the case that for the most part, students end up, being less curious coming out of high school than they were going into grade school, and I believe it was also a Carl Sagan quote. I don't know it exactly, basically saying that's not the result of normal human development. That's the result of the school system, right? There's something happening in classrooms that is teaching people to stop asking questions, and or being curious rather, And I wonder why it is that we ended up there.
Yeah, it's a weird thing. And I've noticed, especially now, I'm doing all these interviews for PhD positions and stuff. And that's one of the things that potential advisors ask first off. I was like, what questions do you have? Like scientifically. I had one the other day. A guy asked me, is like, okay, give me one question that you have that you can answer, and one question that you have that you could probably never answer but want to research anyways. I was like,
Ooh.
those are fun. That's exciting.
What did you say?
So, well, I don't want to give away my research ideas.
Ooh, that's
But
true.
basically,
Hmm.
yeah, but I have, there's a question that I've wanted to work on about craters on Triton, and I have some theories about that and why there's not any craters on Triton. So that's something that I want to look into, but then something that, I could never answer is, I guess I've always wanted to look at the moons of Uranus, especially. There's like 5 of them that are probably big ocean worlds like Europa and Enceladus, but nobody's actually studied
Mm.
them anytime in the last 30 years, like since Voyager went by and took a couple of pictures, and that was kind of it. And we've learned so much about all these other ocean worlds, and nobody's gone back to look at the old data in this new light. Um, which the guy was telling about. He's like, so you want to go on a fishing trip? I was like, yeah,
Pretty much.
basically. I just want to go and see what I can find. There's got to be some cool stuff out there.
Well,
But
I think we'll have the opportunity to ask Dr. Amanda Hendricks about those things in our next interview.
yes,
And I'm actually not sure. I think this episode comes out after that one.
I think so.
We're recording these out of order, so that gets kind of weird. But hey, for the meantime, what do you say we go ahead and start our interview with Dr. Heather Demarest about the
Sounds
philosophy
good.
of science?
Let's do it.
And now we're talking to Dr. Heather Demarest, who is a professor of philosophy here at CU Boulder. She studies the metaphysical implications of current physics. Most recently, her work is on the way in which special and general relativity inform philosophical notions of time, personal identity, and causation. She is the director of the Committee on the History and Philosophy of Science and has also done research on the retention of undergraduate women in philosophy. Dr. Heather Demarest, thanks so much for joining us today.
Thank you so much for having me.
So we'll start off with a general question. How did you come to study science and philosophy together? Were you a scientist interested in philosophy, or a philosopher interested in science, or both, or some other thing?
Yeah, thanks. So I had a little bit of exposure to both philosophy and physics as a high school student here in Boulder at Fairview High School. And I remember being intrigued by both of them because they seem to be asking the same question, which is, what is the world? How do we, come to know what the world is like? And what I found is that they were approaching it from just different angles. So the physicists want quantifiable things we can measure, and philosophers want to be able to know, like, what does that mean for us, our experience of the world, etc. And so what I did was I thought from a very early point actually that I was going to try both. And what I found is I kept getting bounced back and forth. So I would ask questions in physics like, okay, but does a particle have a position when we're not measuring it? And they would say, go ask the philosophy department. And so then I would go to the philosophers and I would ask, according to physicists, particles don't have positions all the time. And they would say, well, that's weird. Go ask your physicist then. And so what I discovered is, to try and really figure out the nature of this stuff, I needed kind of both tools. And so when I discovered that there was a whole discipline, philosophy of physics, I thought, yes, this is perfect.
Now, historically, if we go like way back, most of the most famous like scientists and mathematicians that we hear about, were also considered philosophers. Like I'm thinking of like Aristotle or Descartes or even Newton a lot of times. But more recently, like today, like you're just saying, people consider these to be really disparate fields. These are completely separate things. So when and why did this sort of shift happen?
Yeah, it's a fantastic question. So, philosophy means in ancient Greek, lover of wisdom. So, it kind of covered everything. People who were just curious about anything would be a philosopher. And what we found is that over time, as people were able to make more progress on these certain kinds of quantifiable questions, they kind of peeled off from the central inquiry of philosophy and became their own subdisciplines. And so you're right, this starts happening, around the time of the Enlightenment, the Renaissance and then the Enlightenment. And so you start seeing these kind of, alchemy turning into chemistry and that becoming its own field, kind of somewhat distinct from philosophy. But you're right, at the time of Newton, people were able to ask all these questions. They could kind of be polymaths. They could learn, a little about everything. And because the fields were still so, in their early stages, you didn't have the kind of specialization that we do today. And so I think what ended up happening, the kind of most people actually who were doing physics in a serious way all the way through the 1800s and early 1900s were actually very well trained in philosophical methods and philosophical inquiry. They would all have read Kant. These people just they were embedded right in this kind of philosophical background. It was considered something you had to do. And what we saw in the early 1900s was that there was a particular style of philosophy called positivism. And this style was promoted by the Vienna Circle and a lot of philosophers who were also well versed in physics and in science. And what they did was say, why do we care about this philosophy, this metaphysics? It feels so unverifiable, right? It's not the kind of thing I can put under my microscope or measure with a measuring tape. So, you know what? We are not going to do philosophy. And so, in their minds, they were making an explicit break with philosophy. But of course, now with a bit of hindsight, maybe unfairly to them, we can see that it was really just a particular style of philosophy they were doing. And that was the style of what's now called positivism or verificationism, which said the only things that exist are the things we can measure. And now people think that's a bit simplistic, right? We like think there are quarks, even if we can't see them, because they do such a good job of explaining all this other stuff we see. And so I think after that, though, there was this resistance in the scientific communities to engage in a serious way with philosophy. So philosophy just kind of continued with a lot of people doing this philosophy of physics and thinking seriously about experiments. But the physicists weren't keeping up. And so then you get people like Stephen Hawking or Neil deGrasse Tyson saying very insulting things about philosophers, which I think is just very unjustified because they simply don't know what philosophers are doing. And in fact, philosophers of science who take science very seriously engage quite a bit with scientists who are, interested in these bigger questions or foundational questions. So if you look at, say, interpretations of quantum mechanics, that literature is built up, with authors from both physics and philosophy and working together. So I'm hopeful that, going forward, there can be more collaboration because Einstein had this fantastic quote about this particular philosophy of science. And he said, what I think of Mach's little horse, it can never give birth to live young. It can only exterminate vermin. So that was his way of saying you could get rid of bad theories by using this philosophy, but it wasn't that great at generating new ones. And I think that's, a bit the place we find ourselves if you look at modern physics. We need new theories to somehow show us, how to make consistent quantum mechanics and relativity. But it's hard to know how to do that.
And I don't know if it's maybe that just like physics and astronomy and astrophysics sort of lend itself to a more philosophical view. I mean, we have whole subsets of people who just do theory, but do we see the same sort of thing with like chemistry and biology? Are there theoretical biologists? I don't know if that's a thing or not.
Yeah, no, absolutely. So that's such a good question. You're right. I mean, I think one of the things that philosophy loves to do is ask these meta level questions, right? Like, what about that? And so foundational sciences like physics that look at the very tiniest, or astronomy that looks at the very biggest, or the like large scale picture of the universe, they just are like right there. You're asking these very philosophical questions already. But of course, what about chemistry? What about biology? And there are actually really fantastic ways of engaging philosophically with these sciences too. So Carol Cleland, one of my colleagues here, does fantastic work on the study of life. And so she's asked about the nature of life. What is life? Should we try and define it? She thinks no. And she's actually working like with NASA to try and come up with criteria for how we might go about looking for extraterrestrial life, given that we have a sample size of 1, which she thinks is also misleading because we tend to focus on large animals, maybe plants, but she says multicellular life is very late in the evolutionary history and it's not representative of life even on Earth. So when we go looking for life, if we had as a paradigm, a humanoid, maybe with like a smaller stature and like a bigger head, that's very silly, right?
I got to see one of her lectures one time in an astrobiology class that I took, and it was fascinating.
Fantastic.
Yeah, it was kind of one of those things. After I took that class, I thought I really wanted to do astrobiology, and then I had a bit of an existential crisis and decided I'm going to do geology instead.
Yeah, I think all of us, with a kind of inquisitive mind, are tempted by exobiology at some point. We've all watched Contact.
Yeah, it's a common criticism I've heard of like sci-fi movies and stories in general, is that all of the extraterrestrial life always somehow resembles humans. There's some sort of like head, wherever, and then a body, and that's the creature, which is
yeah, and I think that just highlights how difficult it is to be creative in this kind of way.
Yeah.
Like we assume you see with the normal spectrum of wavelength that goes into eyeballs, but like why on earth would that be, right? Those things, and you'd need arguments for like whether or not they should be universal features or whether they're just contingent based on the type of light our sun emits and the type of light absorbed by our atmosphere and the useful plants.
I'm curious, at what point did this, you mentioned that people like Stephen Hawking or Neil deGrasse Tyson kind of speak about philosophers of science with this sort of almost contempt, right? Like that they're below them. And I wonder when that emotion developed, in the hard scientific community towards the more philosophical community, considering the fact that, as we talked about, scientists were born out of philosophers, or the sciences were born out of philosophy.
Yeah. Yeah, it's a really interesting question. And I think partly it's just historical accident. So, around the turn of the century, like I was saying, at the time that the positivists were coming into their own, there were competing schools of metaphysical views on the continent. So, continental philosophers in particular, some as well in England and the United States, but were really interested in. Both kind of continental existentialist questions, right? Like, what's the meaning of it all? Like, why am I even here? And those kinds of questions are very difficult to make headway with contemporary science, or science at the time, right? Now, with the development of neuroscience and a lot of other psychology and other kinds of scientific fields, you think, oh, maybe we will get some inroads to these questions from a scientific angle as well. But at the time, it was like that couldn't be farther from the practice of science. And one of the other things is the kind of one of the most popular metaphysical views at the time was one called idealism, which was all about, our ideas and how there's no physical world, it's all in our minds. And so it's funny because the positivists are actually a lot closer to that view than they realized, because it's all just what they learned and how they're responding in their context. But they were reacting to that. And so what they wanted to say was like, look, if you can't measure it, what are you even talking about? Right? Like, maybe you're not even saying anything that means anything at all. Like, you're over there, and they would group theology and with metaphysics, and they said, like Hume, commit it to the flames that can contain nothing but sophistry and illusion. And so you have this sense of like, yeah, like what are we even doing? And so as scientists, they thought, let's stick to the data, right? We're not going to do anything but stick to the data. And partly this gave them a way of responding to a lot of pseudoscience that existed at the time, right? Because a lot of people said things like, oh, my theory of psychology can predict any human action. And then you'd go look at what somebody did and then say, yep, my theory can predict that. Right? It's because he didn't get enough love from his mother or whatever. And then someone else would do something totally different. You'd say, my theory can predict that too. Right? He also didn't get enough love from his mother, whatever it was. And so then you'd say, well, what on earth could possibly convince you this theory was wrong? Right? It's kind of like this can predict everything. And one of the things these philosophers, Popper foremost among them, realize is that you can't just collect up a bunch of stuff your theory predicts retroactively, right? You have to make novel predictions, and they have to kind of stick their neck out and give you, maybe they will say something wrong, right? And then you have to say, okay, my theory maybe isn't quite right. And of course, now we know it's way more complicated than Popper thought, right? It might be your experimental apparatus was wrong rather than your theory, and there's all kinds of other stuff that goes into this. And so that's developed a lot since Popper. But I think you can get this sense of like, if we're not able to measure it, then, I'm not okay with it, right? Because like ultimately it's angels on the head of a pin, and who could ever tell? And so I think that kind of idea, right? You'll still see people talk about angels on the head of a pin and how stupid philosophy is, like kind of in the same sentence, as if that's what philosophers are currently worried about. But you see them think, they have kind of this caricature of philosophers as sitting in armchairs, like kind of disconnected from any reality, making stuff up. Right. And they think, well, that's not what we're interested in. But of course, careful philosophy, at least as I practice it and as my colleagues practice it, is really, especially if you're interested in science, is really this kind of, well, there are two ways of going at it. One is the methodological question we've discussed quite a bit already, like what is good inquiry into the world? How can we trust, why do we trust experiments and not our 8-ball? Things like that. But then the other side of it, which is the side I work in, is this interpretive side, which says, given that the equations are so good at predicting the world, at systematizing what we see, what does it tell us then about the world? Like, what you read the Schrodinger equation, you think, that's really complicated math. And then someone says, that's not just math. That's actually how the world works. You want to say, what? How can that be? Like, how does this equation connect up with tables and chairs? And what you see is physicists who ignore philosophy will say a lot of silly things like, well, the chair doesn't exist until you look. You think, aren't I like the chair though? Like, who's looking at me? How does any of this make any sense? And so part of the philosopher's job is to react to that and say, no, let's take the math very seriously, but then see if we can now give a kind of interpretation for like what it is this math is actually telling us.
I had a physics professor once tell me, perhaps controversially, that physics is here to answer the question about why things work, or sorry, about how things work, not why they work. And it's the same thing. I kind of thought to myself, well, why aren't we asking why is this the case? And his answer was because we can't answer that with the tools of physics. You need philosophy or some other field to answer those questions, which I thought was interesting.
Yeah, I mean, so already that's, like pretty good of him, right? To recognize like this is a question and there are people interested in answering it. You have the other school of physics people who are around who are the shut up and calculate, right? Like that's not even a question. Like why, how could anyone ever hope to answer that? And there are also kind of confusions that arise. So, Lawrence Krauss, the physicist, was arguing, philosophy and theology is dead because we now know how the universe, why there's something rather than nothing. And what he meant was, you can see how from a quantum vacuum, oscillations in the background quantum foam give rise to matter, right, and energy. And so you end up with this picture where, in some sense, you're getting something from nothing. But of course, that's not what philosophers cared about. They want to know, why is there a quantum foam? Like, why that as opposed to something else? And so I think there's this, it's very tempting as a physicist to say, I've answered this one super cool question. Therefore, right, these other things that looked similar are silly. And sometimes, of course, that happens, but other times you just kind of miss the point of the question.
Well, at its core, science is really a kind of philosophy, right? People that do science at its highest level are doctors of philosophy. That's the degree that they hold. And popular opinion in the media often portrays science instead as some sort of immutable institution, right? Like it is like the ivory tower, of reality. And I wonder where this disconnect comes from, right? How can we maybe turn it around or explain why it might not be the case?
Yeah, that's such a good question. It is. So absolutely. Physicists who engage in experiment or in theorizing, they have to, in some sense, be, embracing some particular philosophy, right? It might be that they embrace this background view of what the theory is, and then they go work out some particular implication of that. It might be that they think, look, blinding my statistical data is a reliable way to eliminate my own bias, right? So then that's why they do that. There's just so many beautiful, detailed ways that physicists are engaging, or at least making use of different kinds of philosophies, whether they know it or not. And so I think, my plea to physics students everywhere, science students everywhere, is to take a philosophy class, and to really be more aware of those background assumptions that are there, you're using, because if you're unaware of them, you don't know if they're good ones or bad ones. And of course, we learn a lot, right? We learn a lot from our lab. We learn a lot from our teachers in physics who will tell you things like, that's not an appropriate way to run this experiment. And they might explain why in a way that appeals to these philosophical methods, or they might just tell you that's not a good way, do it this way. And you might just say, okay, right? And so you could kind of end up doing good physics, like in spite of your lack of philosophy. But really, to understand it and to do it well and wholeheartedly, it's good to have that training in philosophy. And I think one of the things that's often people are often confused by is they think of science, like you're saying, as kind of immutable, like authority or something. And then that puts people in the position of saying, well, like my pastor also thinks of himself as an authority. And so isn't it just a matter of like faith? Like some people choose to believe science, other people choose to believe religion, and it all comes down to like that. And of course, this is if you take philosophy, you learn like, oh yeah, that is not at all how it is. And one of the ways to see that is to look at how science is actually practiced, right? So you look at the actual philosophical methods, the inquiry, that people do when they're doing science. And one of the things we've learned is that it's a massive social enterprise, right? So nobody's like coming up with a theory and then saying, trust me, right? Maybe in Newton's time, right? And even then he's having debates with Leibniz about the right way to structure space. But now, way more so, just it's suffused, right? You can't escape the community. And so this community of scientists ends up being what makes science so reliable, because it's not somebody in a vacuum saying, trust me, right? It's that if you think you've done a good experiment, what do you have to do? You have to publish your results. And how does that work? Well, you have to submit it for peer review. Other experts end up reading that and looking at that, making critiques. Even if it gets published, people still might object. They still might want to replicate it. If they can't replicate it, that's a big deal, right? And then that becomes the new issue, right? And then if nobody replicates it, then ultimately that proposal is rejected. And so what you get is this really finely tuned machine of human inquiry that exists internationally, right? Across everywhere, there are these standards for what constitutes good scientific practice. And so you have all of this feedback. And so the very fact that it's a social enterprise and that there's so much give and take, there's so much debate, right? You can't just you have to apply for funding. And of course, we know that all this stuff leads to biases. It leads to promotion of what people have assumed. But at the same time, because the rewards for new discoveries are so great, both like in status and in you could win the Nobel Prize or whatever, there's a lot of motivation too to overturn that. And so I think if you don't see this as I think to have an appreciation for why science is so incredibly good and so successful and so powerful. We have rocket ships, we have microwaves, right? It doesn't take a lot of reflection. I mean, and everybody should do this. This is one of my soapboxes I get on, but everybody should take a bit of time to appreciate how amazing our scientific knowledge is. Go take your favorite piece of technology and just meditate on that for a couple of minutes at how impressive that is. Maybe make a call to your family in China, or, watch the next rocket launch or something and just be impressed. Right? And there's a famous argument, a philosophical argument called the no miracles argument. And it says, look, if all this stuff were working randomly, if our science was random, if it was just a matter of faith, what you were happening to believe, the success of science would be a miracle. Why on earth should putting these transistors together on the circuit do this thing? So it's got to be that we're getting the world right, at least in some respect, right? Maybe not totally. Maybe there are still mistakes. Maybe we're not thinking about it in the right conceptual framework, but we're getting something right. And so I think that really underscores, why we should still be trusting science, why science is so important. And of course it's fallible, and of course it makes mistakes. And so sometimes you'll say you'll hear people say it's science, it's a fact, right? But it's just our best version so far. So of course there are going to be mistakes. We know that because there have been mistakes all throughout history. That doesn't undermine the fact that we're getting a lot of it really good.
So this seems to me to be kind of a relation, a comparison between what you value, right? Are you valuing things that can be verified? Are you in search of something that you can show to be true? Or are you in search of something to have faith in, right? And that's kind of your more religious side. I'm curious, my understanding is that older philosophers were also very religious people, right? And I remember in my philosophy 101 class, we read a letter from who, I think it was from Descartes to the church, or some people in the church, basically saying, please don't prosecute me for asking questions about the church. And I wonder, at what point, or is there one, where society started to value verifiable or falsifiable information that science was kind of turning out over, this thing that, the search for faith in something, greater than humankind.
Yeah. I mean, the interplay, of course, between religion and science throughout history is fascinating. It's so complicated, right? There are parts of history that look very, very dark, right? Bruno, amazing scientific work, was literally burned, right, at the stake by Catholics for that. Um, but there's also a lot that is, that works well together. So Descartes' picture was inherently theistic, right? God plays a very crucial role in his philosophy. Newton, right, famously devout. So, of course, they can coexist. They can like be at loggerheads in sometimes brutal ways. So you see that there's this, it's not simple. It would be nice if it was simple. But one of the things we do know is that a lot of religions began or are continued as a way to understand, right? They're like explanatory mechanisms. Like, why is this happening? And then people will say, well, in Greek times, it was like, well, this god was angry, so that's why the storm. You need to make more sacrifices. So it was like, in a way, very, like you can see in the right lens, it's a version of science, right? It gives you something to manipulate. Like there's a purported prediction about what will happen. And so what we see is that as people got better and better at understanding their world, there was less need to appeal to gods, right? Now you can understand why the crops failed is because there just wasn't enough water. Why not? Because there wasn't enough snow. Why not? Well, maybe they didn't know much about climate science at that time, but you see how as you learn more, right, you push, you start to understand it using different lenses. And so some people still think God is a really useful way to understand things like morality, like why is there good and bad in the world? Things like meaning, like what's the purpose of my life? Stuff like that. And so you can see how it has this role to play. I like what you're saying about, the testability, the falsifiability of science, right? Because ultimately, and some people will just deny that God is like this kind of explanatory thing at all. We're not inferring his existence from evidence or anything. It's fundamentally about a like leap of faith, right? There's something really crucial in some religions about that choice to believe in spite of there not being evidence. But there are, of course, lots of philosophers who think there is evidence, right? There is evidence for God, and then that's a separate debate. I think one of the interesting things that does distinguish typical religious belief from science is this idea that, like, ultimately it could be wrong. So almost all religions hold that it's kind of non-negotiable that God is there. And so the debates are about the details of how the explanation goes. With science, it's up for debate, right? It's all kind of, we could be wrong, right? Like we think this is how evolution works, but we could be wrong, right? We could learn that there are other ways. We've now learned the massive importance of epigenetics, right, which outstrips genetic inheritance. And so I think there's a lot to that. This idea that no questioning of it is like questioning it is encouraged and embraced, and we can rejoice and like, oh cool, is there a better way to understand this thing, in a way that's not okay for most religious contexts. And so yeah, I don't there's so much more to say, but I'm going to pause there.
Well, that's one thing that's always bothered me a little bit about, especially like the media's portrayal of science as a thing, because it's very, it is very non-negotiable in a lot of people's eyes. And when something is proven wrong or something changes, everyone loses their mind. And, the first thing that comes to mind is just Pluto. I have to talk about Pluto in every single presentation that I give, because that's one of the questions that people, why isn't Pluto a planet anymore? People are up in arms just because we reclassified a planet into a different kind of planet. And you see this with all sorts of science too. Anytime something changes, it's science said this, and now science says that this is another thing. And
Yeah.
I've never really understood why there's this thought of science being sort of unchangeable, and then just sort of like overarching as science as a thing, and not, these three scientists said this. No, science as a whole says this thing.
Yeah, you see like scientifically proven thrown about a lot. And one of the things that you learn very early if you learn the like philosophy of science is the idea that you can't actually prove any scientific result, because a proof, at least as philosophers understand it, as a logical deductive argument, means you need premises that logically entail the conclusion. And you're just never going to get that with any finite number of observations because of the way logic works. And so you can get deductive proofs for math, you can get those for logic, you can get those for definitions. Turns out that just doesn't get you very much if you want to know about the world. And so what do? Well, we formulate hypotheses we think are, a good way, like a good framework that helps us to understand why things are happening. And what you see is that you can get evidence that goes against that, and you can get evidence that confirms it, but they will never prove it. And so I think this is like a really common misconception in like the popular culture, because people think, well, if it was proved, how on earth could it not be true anymore, right? And so I think partly it's like a bit of like a branding, like terminological confusion. So when you hear somebody say Einstein's theory of relativity, people are like, oh, it's just a theory. You're like, well, yes, but it's also been so massively confirmed. It would be just wild if it turned out it was wrong in any kind of substantial way, right? Like maybe we'll learn, ultimately it has to be reconciled with quantum mechanics. So we know there's got to be some changes, but ultimately, it gets so much so right. And so there's a lot of confusion about that. Like, it's just a theory. You're like, well, yes, but also. And it's the same with proof, right? Like, it has been scientifically proven that. You're like, that just doesn't mean what you think it means, right? What that means is there's like maybe some good evidence for it. If it's in a commercial, it might mean there's no evidence for it. And it just is really, and I think one of the things that's in a way just so sad about like how limited human cognition is, and it's something I like rail against repeatedly, is how like finite our brains are, myself first among them, is like back a few hundred years ago, you could learn all that people knew roughly, right? But now like specialization, like to try and read through a paper that just got published about like a recent result at a super collider, that's really hard, right? And I have like a bit of background to try and read about like the latest result and why some frog population is doing what it's doing. It's like really hard if you're not trained in it. And so I think it makes it really difficult for most people to appreciate what's going on, right? Because it's just super complicated stuff I don't understand, but there's like a lot of complicated stuff I don't understand. And so then it starts to all kind of look undifferentiated. And you're like, well, this guy says it's true, this other guy says it's false. I don't know, right? And partly this is because we've all been fed this myth that like you should think for yourself. And of course you should, but are you actually capable of like thinking with your own mind about any particular issue in the detail that it requires? Of course not. Like nobody is. And so, I think it then leads to this, this big problem where people say, well, I don't know all the evidence yet. Like I got to wait till I like can weigh both sides, evolution or creationism. I don't know. It sounds just very complicated. And it is very complicated. And I think this is why, to like return to what I was saying before about science is this massive social practice. Understanding what that is really helpful in helping people to know like who they can trust, like what results are backed by good methods and what results are just some guy saying it. Because if you don't know about the structure, you're left in this like, I don't know how to differentiate, right? I hear one thing, I hear another. And then lately, of course, with all the stuff in the news and the social media, it's very, very tempting to think, well, gosh, maybe if you just say something loudly, that will make it be the case. And so you get into this very what's called anti-realist view of philosophy, where people, because they don't understand, all this scientific knowledge is removed from our everyday experiences, even from our everyday abilities to understand what the scientists are doing. You end up in this position of like, I don't know if the rubber meets the road. Maybe I'm the one making the road and the rubber. So you then get to say things like, just really loudly, and people will say there's no evidence for that, but you just keep saying it really loudly. And all of a sudden tons of people start to believe it, despite the fact that there's literally no evidence. And I think that just comes from not necessarily a lack of knowledge about the content itself, because that's just really difficult, but it comes from a lack of knowledge about what science is, right? Like about this practice in general.
So looking at your work in particular, one of the things that you talked about was how relativity informs our philosophical notion of time, which I think is fascinating. I love the whole idea of studying time itself, but how does reality inform our philosophical notion of time?
Yeah, awesome. I also find this super fascinating. So I think the easiest way to appreciate this is to think about how people intuitively think about time and the way that historically people thought time was. So like Newton, like what was time like for him? And the idea you get there is there's a now, right? There's like a present moment for everybody. And then we change, right? Things happen. And then it's a later time for everybody, right? And what we've lost with relativity is that the tenability of that picture. One of the things that, there are lots of things we just think are kind of trivially true about time. So time passes, right? Like used to be a different time and later it'll be a later time. And in the middle of that, time is passing or flowing, right? Or I'm moving through time. You also get that you're fixed. Like, so you can't decide to like go to next week. You got to just wait patiently. Same about the past. And that feels really different from space, right? You can go anywhere you want in space. Lots of things like that have to do with the fundamental asymmetry of time. So I remember the past, but I've never remembered the future. I feel like I have control over the future. I feel like I can determine what's going to happen. It feels open to me in a way that the past is not, right? I can't, no matter how hard I try, I'm just not going to change any facts about yesterday. And so those are really, they dovetail very nicely with this intuitive picture of there being a now that exists for everybody that's moving, right? Everybody else is experiencing the same thing. We're all trapped in this moment that's moving. And what we get from relativity is just such a different picture, because what relativity says, and I know I'm repeating myself for you guys, but maybe the viewers will appreciate a little bit of background, is the idea that there is no now defined by special relativity. So according to the theory of special relativity, what events you think of as being simultaneous with you now is different from the events that someone else might take to be simultaneous with them now, even if they now are in your now. So what we get from this is simultaneity is not transitive, is the word philosophers use. So that means that things that are simultaneous for me might not be simultaneous for somebody else, right? Even if that person is simultaneous for me. So now you're in a bit of a pickle, because if you had thought that only things that exist are the things that exist now, right? Like, do dinosaurs exist? My kids ask, and I'm like, no, sadly, they all died. And then one of them will say, what about chickens? I'm like, okay. So the idea is like, if you think that that's plausible, things in the past don't exist anymore, things in the future have yet to exist. What does special relativity have to say? Well, all of a sudden it looks like existence depends on your state of motion. So the things that exist for me are determined by what I would call my rest frame, or basically how long, right, it took light to reach me a bit later from those events. You can operationalize it that way. But then somebody else, what events exist for them is going to be these events. Some of those are in my past, and some of those, somebody else might be in my future. So according to this way of looking at the world, it may well be that if you think everything that exists now exists, and you think that special relativity is right, there are no I'm not like the special person for whom it's actually my frame that's right, then by transitivity, I get that literally every event exists. So what that means is that all the future events are already there. Well, the past events are there. They exist now in some kind of sense, right? Not like according to my frame, but according to a frame that's according to my frame, right? So you end up having to say, okay, well, what does that mean for the passage of time, right? If those points are there, if like Heather exists 5 minutes ago talking, and here I am, and Heather exists 5 minutes from now. What does that mean? Like, why can't I experience things through there? Why does it feel as though I'm moving? You end up with a lot of these puzzles. And so another fun puzzle that arises from general relativity is the idea that time passes differently depending on where you are in a gravity well. So if you're very close to a gravitational object, time is slowed down. And if you're farther out, time is not, or it's slowed down less. And so what you get is, it used to be that philosophers thought a person's identity was basically, so you can even get this in special relativity. If I think, what am I think I'm just like a stack of like persons at different times. You start to get puzzled when you look at general relativity, because if I, right, am in that gravity well, and this part of me is moving more slowly than this part of me, as it is every night when I lay down at, my pillow, then what are those, like, there's nothing to stack up anymore, because you get like, one side of me is always moving more slowly than the other side. And so now I can't even say that I'm like made up out of these time slices or something at moments. And so these are two of the questions that I've spent a while writing on and wrestling with.
One last thing we did want to talk to you about is this committee on the history of philosophy and science, which I think is fascinating. But what's the sort of purpose behind this? What are you guys trying to accomplish with this committee?
Yeah, good. Nothing too grand. I mean, it's not like we're, gonna go build a rocket or anything. The point of the committee is to be a place for this kind of interdisciplinary connection. So we have like distinguished speakers we bring out, who usually, the most recent one, Lisa Bortolotti, she talked about delusions. Like, what is a delusion? What's the right way to characterize a delusion? Can it be any mistaken belief? Does it have to also be connected to some kind of psychological pathology? How are pathologies even defined? So it was really an interesting, philosophy of psychology talk. And we had both psychologists and philosophers in the audience. And then we've had talks by philosophers of physics, philosophers of biology, and the idea, so that's the distinguished speakers series. So we bring out some really amazing speaker, this time by Zoom, and they tell us all about what this particular field is like, or their question they're asking. And then we have a conference once a year where it's a more focused, we're all going to talk about the laws of nature. What are they? Do they push and pull, or do they just describe, right? You have all these kind of fun debates. And then the other thing that we do at a more local level is we have coffee talks where we'll invite people, right, from like NIST or GILA or physics or, neuroscience and psychology, to just give like a work in progress kind of discussion talk over coffee. Like, this is stuff I'm working on. What do you think? And partly that's because the fruitfulness of this exchange is so great, right? Like, if you're just doing philosophy and not paying attention to the science, I think that's a disaster, right? Then you just are in your armchair. But if you're just doing science and you're not paying attention to the philosophy, again, it's a disaster. So what you want is this interaction, right? So that you can say like, hey, what do you think of this new experiment? One of the fun ones we had, Christer Schalm over at NIST was doing an experiment on entanglement. So these particles that get far apart, there's this question, because they're correlated at a space-like distance, meaning there can't be a light signal that goes from one to the other. They nevertheless show these correlations that statistically demonstrate they couldn't have been existing. So there's this question of like, how on earth are they correlated then? And so one of the questions he was looking into was closing these loopholes, right? So that looking at like designing a more and more careful experiment so that you could tell, okay, there was no light that could have made it here. There was no light that could have made it here. These are how the random things were set. And that was a fabulous kind of interaction, right, between philosophers who want to know about causation and like signaling, and physicists who are just doing this experiment.
Well, I think that's that last question about, I think what we'll ultimately call quantum entanglement is a perfect segue into a segment that we do on the show called Capcom Q&A, where listeners send in their questions for us to pass on to you to answer, because you're the expert. And so the first question comes from us from Anya in Westminster is, how does the current philosophy view quantum mechanics, especially quantum entanglement, and the possibility of a single wave function for the whole universe?
What a wonderful question. And to do it any kind of justice would take much too long. But philosophers in general have actually had quite a lot to say about quantum mechanics. And partly that was because of the softball we got from physics in the guise of the Copenhagen interpretation. As I alluded to before, the Copenhagen interpretation says that the thing doesn't have a determinate state until it's measured. And so, of course, you immediately want to know, well, what's a measurement? And there's no good theory for that. Partly because the measuring device, if it's you or if it's like a box on the table, those are made up of quantum systems. There's no reason to think they're kind of exceptions. And so to make this massive distinction between classical physics interacting with quantum physics feels like it just can't be the whole story. This was Einstein's complaint from the beginning. It can't be complete. So what you have, because you have this classical picture and you're using the classical to affect the quantum system, when ultimately the classical system is supposed to be built out of the quantum system. So there are a variety of cool interpretations offered that philosophers like to consider. So one is called the Bohmian interpretation, and that does posit a universal wave function for the whole universe. And it also posits particles. And the basic idea is that the particles are pushed around by this wave. So you don't have any problems with measurement. You don't have any of this stuff that arises for the Copenhagen. There's another theory that's really popular among philosophers and is gaining some traction with physicists too, called the Everett many worlds interpretation. And that idea is there's, again, a universal wave function, and that wave function can go into a superposition. So you see the alive cat and the dead cat. If you don't know that, go look up the Schrodinger cat experiment. Thought experiment, thankfully. And what happens is those two superpositions, then we can think of them as being distinct worlds. So one world in which the cat is alive and the other world in which the cat is dead. So you end up now with these two worlds where both outcomes determinately occur, one in each world. That explains why you can't see the other one. So you're constantly splitting on this view. So how does this relate to entanglement? How do philosophers think about entanglement? Entanglement is really tricky because it seems to be a causal, it has all the hallmarks of a causal connection. Why? Because there's no common cause that can explain it. We know that they come from a single source, but it's not enough, partly because of the way the statistics work out for the entanglement. And so there's this question of, if there's not a common cause and yet they're correlated in this way, did this one cause this one? Or did this one cause this one? Or something else? And so one of the things people have been very puzzled about is how this is consistent with relativity. Special relativity says you can't have causation faster than light. But that's because causation goes by way of light or mass. Now, there's no light or mass being exchanged here. So some people say, well, it hasn't violated the law of special relativity, just the spirit, because there's this correlation that we can't use to signal. Doesn't seem to be any transmitted information, but it's so puzzling, right? Because it exists at like any arbitrarily large space-time distance. Yeah, all kinds of reasons. It's a perfect correlation, right? It doesn't seem to affect anything else aside from its like entangled partner. And so philosophers have wondered, like, what does this mean for causation? Any theory of causation is going to have to handle this. And it gets pretty tricky.
Super tricky. So maybe a slightly easier question here from Ray from Georgetown wants to know, how does philosophy enhance perspectives on climate change?
Good. A whole variety of ways. Lots of philosophers work on climate, both climate science and also, the ethics side. So a lot of people, there's a lot of interaction between philosophers and environmental science. And so they ask things like, what are our moral duties to people who are affected disproportionately by climate change? That's like a straightforwardly philosophical question. Like, what does justice demand of us? What should we think about the fact that like certain people are going to be protected from a lot of the consequences of climate change, other people are not? And that doesn't tend to be very equitably distributed. As far as the philosophy of science, qua science goes, there's a lot of really interesting stuff about how to think about climate science, right? Like, what kind of science is it? When you look at historical records, you have historical science, and those types of inquiries are often characterized slightly different from like a straightforwardly experimental science. So you can set something up in the lab and run it, but of course we can't do that with the climate. It's too big, or it's historical, right? So you can't go back in time and set up your initial conditions. So there are different methodological standards that come into play. And so philosophers who are concerned with climate science are really interested in those kinds of constraints, right? So we can be really good at building models, climate models, and you might think, okay, so when should we be confident that our climate model got it right? One of the problems is you have an overabundance of models. And so there's a problem of like fitting too well. So you say, oh, this perfectly matches what we've seen. And then it goes on to like not match at all when you look at new data. And so there's a lot of this that goes into, and a lot of scientists who work in climate science are very concerned with this too. So there's like a lot of good exchange there.
So this next question is just a straight question to you and your beliefs. Charlotte from Austin wants to know, do you believe in sentient life beyond Earth? Yes or no?
Man, that's a tricky one. So I'm going to tell you the total cop-out answer, which is like, I hope, and like, there's no reason to think there shouldn't be. We don't have any evidence yet, so like maybe I should like withhold. But I guess I would probably say, so I've thought quite a bit actually about the Fermi equation and like, what are the variables here? And I've read some interesting work that tries to pin down some of those. And so I would say, if I go with reasonable numbers for those, then yeah, I think it's likely there's sentient life.
Totally.
The Drake equation. I called it the Fermi paradox. I thought a lot about in terms of the Drake equation.
There you go.
My brain was like, something wasn't quite right.
And our last question from the audience here is from Allie here in Boulder, who's asking about the dark forest theory. She was wondering what you know about it and what are your thoughts about it?
Oh, I'm gonna be a huge disappointment. I don't know the dark force theory.
I don't either. So
okay. Maybe
sorry, Allie.
Better. Yeah, I don't know. Okay, but always happy to learn about new theories. So
maybe Allie can check that out for us and show on the show sometime and give us a quick briefing on this dark
totally.
forest theory.
Leave a comment or something.
Yeah, right.
There you go.
Cool. Well, that wraps up our Capcom then. That was our last question for the day. Sorry, Allie, we don't have a rock-solid answer for you. Other than that, hey, thanks so much for joining us today. It has been such a pleasure to talk with you about the philosophy of science.
Yeah, thank you again for having me. It was a treat.
Got a ton to think about now.
Great.
It's going to be a long couple days following this episode.
Well, as any good philosopher, if I've made you think, I've done my job.
There you go. There you go. All right, and that wraps up our interview for the day with Dr. Heather Demarest. We'd like to say thanks again for coming onto the show and having this great discussion with us about the philosophy of science. And I also want to remind everyone to check back in next week for a conversation with Dr. Jack Burns, who, among other things, does space policy. So we're going to be talking about, how do we regulate and make rules about the way that humans interact with space and internationally. So that was a really great conversation. Looking forward to that episode too. Hey, if you ever feel inclined to do something with some free time that you might have on your hands, go ahead and check out our website, colorado.edu/FISC. There's a whole bunch of great stuff there, a whole treasure trove. And among other things, you can submit your questions to us. We'd love hearing questions from listeners and forwarding those on to our experts. So please go ahead and do that. And of course, this will depend on who we're coming up to interview. But you can also find that schedule on our website. Every time we release a new season, it's on the website. So check it out. And another thing you can do, and this is one that we really appreciate, is you can make a donation to the podcast. Hey, if this is important to you and you like listening to the show, you can be the reason the show exists. So go ahead and check that out. Again, that's colorado.edu/Fisk. This podcast is available on YouTube, SoundCloud, Spotify, and Apple Podcasts. Go ahead and subscribe to wherever you're listening so you don't miss any episodes. And I guess we'll see you next week. Thanks for listening.